People in the chat, Q&A bit, can let us know if they can see this now. It works. We've got it. We've got thumbs up all round. Great stuff. We've got through this. Right.
Oh, good. Okay.
Tom.
Excellent. So, yes, as I was saying, I'm going to run through what the existing literature tells us about the uptake and also the morphology, constructed morphology of these features and some of the challenges that presents us. And then I'm going to introduce a conceptual framework which sort of works within that and hopefully is useful. So, sand dunes are complex geomorphic landscapes where the interaction of sediment transport, wind, rain, and the sea interact. And these areas of bare sand and transitional zones are important habitat for numerous species and are also important for allowing the transport of sediment into, out of, and within the dune systems. And on the diagram, blowouts, very important features within sand dunes in creating those bare sand and transitional habitats. In many places in the temperate regions, in the absence of some form of disturbance or control, vegetation establishes and then through classical ecological succession builds up, forms soil, forms taller, coarser species, which then stabilizes the dunes more and more and reduces this bare sand areas. Globally, there's been a reduction in bare sand across dunes, and this is especially prevalent in Europe. And that's happened for at least the last 100 years. And there is some contention about whether that is a good thing, bad thing, natural thing, anthropogenic thing. But it is an occurrence that's happened. You can see a transition of a reserve in Belgium from 1948 on the left through to 2005 on the right. And then this diagram from Jackson et al. 2019 shows some of the drivers of this. And that has led to an increase in vegetation cover and the morphological fixing of dunes. In response to this, we have Foredune notches. So these two diagrams demonstrate quite nicely what they are, what they look like. So the diagram on the left is from Smith et al. 2025 and shows how they are literally a gap in the foredune. And that is demonstrated within a bit of a wider landscape view in the diagram on the right. And these are designed to allow sediment transport from the beach into the middle, hinter, and back dunes. So what the research tells us, well, some nature conservation have promoted these interventions quite heavily, and they have uptake within Europe and New Zealand, which we'll come to in a sec. However, there's very little information available about their form or functioning beyond a single site level. What is shown by these papers and the papers shown below are more or less all of the papers and research that's been published on these features. And what they show us is that the measurements reported vary quite considerably. So, for example, reported widths range from 6 meters to over 110 meters. However, as you can see in the titles of these papers, they're all just described as notches without much further qualification. That contrasts with blowouts, for example, which have trough, saucer, bowl, and further qualifications to description, which describes them better. This also leads to the question of how do these differences in their constructed size and shape affect their functioning in terms of aeolian sediment transport and their morphological evolution and stability. again, relating this to blowouts, what we know is that differences in morphology affect their functioning, and therefore to be expected that the same would be true in notches. However, these single site studies are quite hard to compare because they call all notches notches, and you can see on the collection of photos, they all appear quite different. So to research this, we first had to identify notches globally. And we did this by looking through grey literature, scientific reports, consultancy reports, and similar. So this led us to identify notches globally that have been constructed. So you can see here, we have 133 notches across 20 sites. We've got UK and the Netherlands. And what's quite interesting is they are quite clustered within these countries. And then further, we have New Zealand and France. On both countries, it's just one site, and they're both quite interesting. New Zealand notches are quite different to all the others. They're much smaller, and their purpose within the literature is actually to build Foredune resilience and to grow the dune. That's in contrast to the other notches globally which have a role much more emphasizing the habitat creation. Notches in France were constructed on a research site for the reasons of research. This allows us to be able to analyze their constructed morphology using aerial imagery from as close to the point of construction as we could find. Measurements were based on those used in the existing literature, but refined slightly to work with the data that was available. So again, reflecting how blowouts are termed and measured, we've got longshore landform width, cross-shore landform length, and then slot width as well. An interesting result was the presence of notches which had multiple slots leading to a common lobe. So that was displayed on the right. From left to right below, you can see the measurements, and I don't want to get into the exact measurements within this talk, but what I hope you can see is that there is a lot of variability within countries, within sites, and also overall for all key measurements. So that led us to create this diagram, which tries to capture the variability within that in a way that could be used to transfer between sites, within sites, and within research. So we have a better way to describing them rather than just saying notches. So we have minor notches, such as those used in France, which are much smaller and tends to be quite a narrow slot. Then have rectangular notches, what we have termed slot and lobe, which have a very defined slot and then a much larger lobe. And again, possibly most interesting is what we have termed composite notches, or diagram F, which has multiple slots, sometimes more than 2, sometimes 3, as is shown in this diagram, leading to common lobe. And again, that's something that's not really been reflected within the literature so far. And that's interesting because, as you can see from these different shapes, we would expect different aeolian functioning within that, leading to different evolution, morphological evolution, and different patterns and types of sediment transport. And that is what future work is going to be looking at. So this is some very preliminary work based on just one site, and this is very much work in progress. But what can see is we have on this site 2 types of notches. So B and E, so B being that rectangular notch, and E being a very elongated notch. We can see the type E notches on this site at least show more variability over time. So indicating they might be more dynamic and less stable and less able perhaps to maintain their function over time, which is a key purpose of notches. And again, this is very much work that's ongoing and is continuing on other sites, but this is where hopefully this conceptual system might be useful. So to summarize, Foredune notches be constructed in Europe and New Zealand. France and New Zealand ones are quite different and quite unique. But having said that, across all sites, they are very variable, but it's not reflected in the literature or in the language that we use. So some kind of framework similar to that used in blowouts or other features as well might be useful in clarifying research. And initial evidence from ongoing work suggests that this variability does impact the morphological evolution of these features. And that is the presentation.